Hey you guys, welcome back to another video. Today we're going to be reviewing for our fourth 9 weeks midterm. Let's start with question number 1. It says, given the function f of x equals negative 2/3 to the power of x minus 4, select the correct transformations. Okay, so I can identify this as an exponential function, and I know that because x is in the exponent. So with any exponential function, you have, of course, the exponent and you have the base. So this 2/3 would be considered the base. So I'm going to say the parent function is f of x equals 2/3 to the power of x. Okay, this is an exponential function. And because the base is 2/3, which is less than 1, we know that this will be exponential decay. Okay, after you have identified what the parent function is, any number that was not highlighted as part of the parent function would be some kind of a transformation. I'm going to refresh your memory on the equation for transformations. You have a times your base to the power of x minus h plus k, where a represents, and I'm going to abbreviate here, your vertical stretches or compressions. This h represents your left and right, and the k is your up and down. Okay, so here I see that we have a negative, so this will be a reflection. And because it's outside of the x, so remember, inside the house would be anything with x. So inside the house for us, for exponentials, would be considered whatever is in the exponent. But because it is outside of the house, this would be a reflection over the x-axis. Okay, now this is highlighted, so you're going to ignore that. These are not transformations. So I'm going to move on to this minus 4. This minus 4 right here would indicate that we went to the right 4 units, because remember, everything inside the house is the opposite of what you think it is. It is a lie inside of the house. And then this minus 4, it's outside the house, so it is the truth. This would be going down 4 units. So let's go through the answer choices. We did go down 4. We did go right 4. We did not go left. There was no horizontal stretch, but there was a reflection over the x-axis. So the correct answer choices would be A, C, and D. Okay, let's go on to question number 2. Given the function f of x equals 3 divided by 2 times log base 3 of x minus 5, select the correct transformations. Okay, so what I'm going to do again is refresh your memory on the equation. So it's a times log base b of x minus h plus k. And then it's the same thing, vertical stretches and compressions, left and right, up and down. Okay, so what you want to do first is identify what the parent function is. So to do that, you find x. There's x, and then in front of that we have log base 3. So all of this is the parent function. Okay, so I'm going to write that here. The parent function is f of x equals log base 3 of x. Now notice that in this equation, if you're going left and right, it's going to be wrapped in a set of parentheses. This minus 5 is not in any kind of parentheses, so we are going to be safe to assume that this x is by itself inside the house. Okay, notice the difference between this one that had no parentheses prior to this one. If they are intentional about putting parentheses, then they're going to let you know for sure this is left, this is right, this is up, this is down. In the absence of parentheses, you're going up or down. If it's in the parentheses, then it's left and right. Okay, so anyways, this 3 over 2 would be a vertical stretch because 3 over 2 is more than 1. And then all of this is highlighted, so remember, anything that's part of the parent function would not be a transformation. So the only number left would be this minus 5, which means we're going down 5 units. Let's look through the answer choices. There was a vertical stretch. We did not go to the right. There was not a vertical compression, and we did go down 5. So the only answers are A and D. Okay, moving on to question number 3. What is the asymptote of f of x equals log base 3 of x plus 4 plus 5? So I'm going to identify the parent function. This is obviously a logarithm. So you start highlighting from the word log until you reach x. Okay, now what are the transformations? That plus 4 is inside of the house, and inside the house is a lie. So this is going to the left 4. And then this that is outside the house, we're going up 5 because that is the truth. Okay, now what kind of asymptote do logarithms have? Remember that log, when you write the letter L, it goes up and down similar to a vertical asymptote. Okay, so let's sketch this. Now the vertical asymptote is usually at x equals 0, but we went to the left 4, so it'll be shifted over here. So I'm going to draw a vertical asymptote at x equals negative 4. Now moving up 5 units, it doesn't matter. Okay, so the graph would look something like this. And you can use your graphing calculator, of course, to double check this, but we can conclude that the vertical asymptote is at x equals negative 4 based on the transformation that we went left 4 units. Okay, so let's go on to question number 4. What is the asymptote of f of x equals negative 5 to the power of x minus 2? Okay, I'm going to highlight my x. Now this is an exponential. I know that because the x is in the exponent. And the number immediately before that is the base. Okay, so this is an exponential function. And b is 5, so that would indicate exponential growth. Okay, because b is 5. So what transformations do we have? This negative indicates that there was a reflection over the x-axis. And this minus 2 is in the exponent, so I'm going to put parentheses around this. That is considered inside the house. So minus 2 would be to the right 2 units because everything inside is a lie. Now this is an exponential, so what kind of asymptote do we have? If you draw out the e for the exponential, it ends up looking side to side like a horizontal asymptote. Okay, so if we were to draw this, normally a horizontal asymptote is at y equals 0. Okay, so do we have any transformations that affect this? The reflection does not change it, and the right 2 units does not change it. The only thing that would change the location of y equals 0 is if we went up or if we went down. But because we did not go up or down, we know that the horizontal asymptote would stay at y equals 0. So I'm going to draw this HA at y equals 0. Okay, and then the graph, since it was reflected over the x-axis, would look something like this. Okay, so the correct answer would be D as in dog. Let's go to the next question. Number 5 says, what is the domain of f of x equals 2 times 3 to the power of x minus 5? Okay, this is another exponential function. The x is in the exponent. This 3 is considered the base. So now let's identify the transformations. This 2 would indicate a vertical stretch of 2. And this minus 5, notice that it is not with x. So inside the house is just x. There's no left or right. This minus 5 means that we went down 5 units. Okay, and we said this was an exponential function, and exponential functions have horizontal asymptotes. So let's make a sketch, or you could also use your graphing calculator. Now, normally the HA is at y equals 0, but we went down 5 units, so I'm going to shift this all down 5. So I'm going to say that the HA is somewhere down here at y equals negative 5. Okay, and then from there, the exponential, there was no reflections, and the base was 3, so that is growth. So the graph would look something like this. So what is the domain? Remember that you read domain from left to right. So on this side, it goes forever to negative infinity, and on the right side, it goes forever to positive infinity. So the answer would be D as in dog. Okay. Now, question 6 is the same exact equation, 2 times 3 to the power of x minus 5, but this time it says, what is the range? The range is read bottom to top. Okay, so let's go back up to our sketch. Bottom to top. The lowest y value would be right above this horizontal asymptote. Okay, because remember this part is going to approach the horizontal asymptote, but it cannot cross it. So the lowest it can get is really, really close to -5. And then how high can it go? Well, I see this arrow going up to positive infinity. So that means that the range, the lowest y value is -5. So I'm going to pick answer choice A. It does not go down to negative infinity, so all of these are eliminated. And because the horizontal asymptote changed and it went down 5, it cannot be C either. Okay. The reason for the parentheses is because of the horizontal asymptote. You can never touch the asymptote, therefore you cannot use brackets. Brackets are reserved for closed points or solid lines, and parentheses are reserved for asymptotes or infinity, or open points. Okay, let's go on to question number 7. What is the range of f of x equals -2 times log base 2 of x plus 2? Okay, so I'm going to identify my parent function. This is log base 2 of x. That's the parent function. The transformations are as follows. We have a reflection over the x-axis, a vertical stretch of 2, and then this plus 2, it is not around parentheses, so that means that this x is by itself. This plus 2 would indicate that we're going up 2 units. Okay, so let me draw a sketch. A logarithmic graph, so remember a log, when you do the L, it goes up and down similar to a vertical asymptote. The vertical asymptote is usually at 0, x equals 0, unless you shift left or right. But because we did not move left or right, then that means the VA is staying at x equals 0. Okay, and then there was a reflection over the x-axis, so instead of it normally it goes up and to the right, this time it'll go down and to the right. So it'll look something like this. Okay, what is the range? Range is bottom to top. On the low end, it goes down forever to negative infinity, and on the high end, it goes up forever to positive infinity. Therefore, the range is D, all real numbers. Okay, let's go on to the next question. What is the domain of f of x equals -2 log base 2 of x plus 2? That is the same equation we just had, but this time we're solving for the domain. Remember that the domain is read from left to right. So on the left side, there's nothing here. So that means the graph has to start after the vertical asymptote, which is at 0. So this graph is going to approach the vertical asymptote, but it's not going to touch it. It's not going to cross it. So the smallest x value would be approaching 0. And on the right side, it keeps going to the right. And on the right, you have positive infinity. So I'm going to eliminate a few answer choices. I cannot go to negative infinity because I am restricted by that vertical asymptote. And then we did not go to the right 2 units. Okay, so the vertical asymptote stayed at 0. The answer would be C. Question number 9 says, rewrite the equation 2 to the power of 9 equals 512. What we're going to do is, this is an exponential function, so I can rewrite this as a logarithm because they're inverses of each other. So what you do there is do your loop-de-loop. So I'm going to underline my base, which is the first number, draw an arrow out to the last number, and then come back into the middle. Okay, now when you go from exponential to logarithmic, the first thing you need to write is the word log. And then from there you follow the order of the numbers. So we have log base 2 of 512 is equal to 9. And the answer would match answer B. Okay, let's go on to question number 10. What is equivalent to 1/3 to the power of x plus 1 equals 9. Okay, I can also rewrite this as a logarithm. This is an exponential function. I know this because x is in the exponent. So I'm going to do my loop by underlining the base, draw an arrow out, and then come back in. And I'm going to start by writing the word log. The base is 1/3. And remember, the base has to be small. Don't write it too big, and it should be a subscript. It should be underneath the word log. And then the arrow leads you to the number 9, and then it leads you to x plus 1. Okay, that would match answer choice D as in dog. Okay, question 11. Now this is a logarithm, so when I rewrite it using the loop-de-loop, it'll be in exponential form. So I'm going to underline the base, go out, and back in. In exponential form, you start with 3 to the power of 7 equals x minus 2, which matches answer A. Okay, let's go to the next question. Number 12, what is equivalent to log base 5 of 8 equals x plus 2? So I'm going to underline the base, go out, and back into the middle. This would be 5 to the power of x plus 2 equals 8, which matches answer B as in boy. Okay, now we're actually going to start solving. So right there, we were just practicing how to do the loop-de-loop and how to rewrite from exponential to logarithmic and vice versa. We weren't actually solving for x. Now we're going to do those same steps, but we're actually going to isolate x and solve. Okay, so solve 1024 to the power of x plus 1 equals 16 to the power of 5. Now, because I have an exponential on both sides, remember that the first thing you should always attempt is try to get a common base. And then if you cannot get a common base, then you can do your loop-de-loop and rewrite it in logarithmic form. Okay, so 1024 and 16. Let me see if I can find a common base. I know that 16 is 4 squared, so maybe 1024 could have a base of 4, but it's just going to be trial and error. So I'm going to start with 4 to the power of 1, 4 squared. Okay, you see I got the 16 that we needed. Now let's keep going, see if I can find 1024. The 4 cubed, 4 to the power of 4, 4 to the power of 5, and there it is, 1024. That is what we needed. So the two numbers I'm going to use are 4 to the power of 5 and 4 squared. So I can rewrite 1024 as 4 to the power of 5. However, it is still being raised to the power of x plus 1. And 16 can be rewritten as 4 squared, and it is already raised to the power of 5. Now that we have the common base of 4, you can kind of just ignore them, and all you're going to focus on is setting the exponents equal to each other. So we have 5 times x plus 1 equals 2 times 5. We're going to distribute, and you're going to get 5x plus 5 equals 10. Now we just need to isolate x by getting all the x's on one side and the numbers on the other side. So I'm going to be doing reverse PEMDAS. I'm going to subtract 5. That gives me 5x equals 5. Then I'm going to divide by 5, and we get that x equals 1. Okay, so I'm going to box that in. Now, it is a good habit to go back and plug it into your calculator and make sure that it is true. So I'm going to do 1024 to the power of 1 plus 1 equals 16 to the power of 5. And it says true, so then we know for sure that our answer is correct. Okay, let's solve question number 14. Now, this is another exponential. This one has a base of e. So here is my x, here is my base. So that means that anything that is not part of that, I'm going to have to move it so that I get it isolated. So I'm going to do minus 6. Okay, so now we have negative e to the power of 2x minus 3. This cancels out, and I'm left with negative 4. Now there is a negative in front of the base, so that is being multiplied. You could add the imaginary 1 if you want. So I need to divide both sides by negative 1. That will leave me e to the power of 2x minus 3 is equal to positive 4. Now, I cannot get a common base between e and 4, so what I could do is rewrite this as a logarithm. I'm going to underline my base, draw an arrow out, and then come back in. But any exponential with base e is a logarithm with base e, which is rewritten as the natural log. So we have the natural log of 4 is equal to 2x minus 3. Now I do still need to solve for this, because I need to get x by itself. So we're going to do reverse PEMDAS. I'm going to start by adding 3 on both sides. So now we have the natural log of 4 plus 3 equals 2x. Then I divide by 2. So x equals the natural log of 4 plus 3, all divided by 2. But the question did not say leave the exact answer. It did say round to the nearest hundred. So let's start. In the calculator, I'm going to open up a fraction first. I'm going to type the natural log of 4 plus 3 divided by 2. And then mine is a little bit different than yours. I need to put a period to get a decimal. So we have 2.19. So x equals 2.193. It was, right? Yeah, 193. And then to the nearest hundredths, that's 2 places after the decimal, and the 3 does not round up. So 2.19 is the final answer. Okay, let's try another one. Solve 100 plus 10 times 3 to the power of x equals 560. I need to isolate the parent function, which is starting with this x and the base of 3. So I'm going to start by subtracting this 100. We get 10 times 3 to the power of x is equal to 460. I'm going to divide both sides by 10, and we get 3 to the power of x is equal to 46. Okay, I'm going to be able to rewrite this. Underline your base, do your loop-de-loop. And when you rewrite, remember that you have to recognize that we started as an exponential. So when I rewrite it, it'll be a logarithm. Log base 3 of 46 equals x. Okay, now we have isolated x, and if the question said leave it exact, we would be done, but it didn't. It said round to the nearest tenth. So I'm going to go to the calculator and type in log base 3 of 46. And it happened to me again. I need to add a period to it. .484. Okay, 3.484. And it said round to the nearest tenth. That is 1 place after the decimal. So what you do is, if you need this one, you look at the one before. And this 8 is higher than 5, so we're going to round up. So this rounded answer would be 3.5. Okay, on the next one, we're going to solve for x again. Here we have an exponential. I have the exponent and the base. Okay, so I'm going to start by doing reverse PEMDAS. I'm going to subtract 600 because the first thing you want to do is isolate the parent function. Okay, so 2100 minus 600 is 1500 equals 920 times 1.06 to the power of x divided by 8. Then I need to divide both sides by 920. This cancels out. Let's see if that fraction reduces. So the fraction was 1500 divided by 920, and it reduces to 75 divided by 46. 75 divided by 46 is equal to 1.06 to the power of x divided by 8. Okay, now at this moment, we need to do the loop-de-loop so that we can rewrite this from exponential form to logarithmic form. But I would recommend that you swap the order because we're used to doing the loop in a certain way where the exponential or the logarithm is on the left-hand side and what it's equal to is always on the right-hand side. So what I'm going to do is just flip it around so that when I do my loop, nothing changes, okay? So I'm going to underline my base, go out, and then back in. Now, this is not a necessary step. This is just for those of you who have been getting confused when things are on opposite sides of the equal sign. So I'm going to start by writing the word log because we're switching from exponential. The base is 1.06 of 75 over 46 equals x divided by 8. Now to isolate x, I need to multiply by the denominator, which is 8 on both sides. Okay? So this is what I'm going to plug into the calculator. We have 8 times the log with base 1.06 of 75 divided by 46, period. And we get 67.115. 67.115. And it said round to the nearest tenth, which would just be 67.1. Okay, let's do one more. This one is a logarithm. So this is considered kind of like my parent function. I need to get everything else. I need to get this isolated. So I need to add this 12 because we're doing reverse PEMDAS. So we have 5 times the natural log of 2x minus 9 and then 18 plus 12, which is 30. We're going to divide both sides by 5 so that these cancel out. And we have the natural log of 2x minus 9 equals 6. Okay, now I need to get this x, but it is inside the parentheses of the natural log. So the only way to get rid of the natural log is to rewrite it as an exponential. And remember that every natural log has base e, so I'm going to add the e so that I can underline it and then do my loop-de-loop. And then this would be e to the power of 6 equals 2x minus 9. Now we're not done because we do need to solve for x. So I'm going to do reverse PEMDAS again. I need to add 9 on both sides. And then I'm going to divide by 2. Okay, so I'm going to put that right into the calculator. E to the power of 6 plus 9 divided by 2. I'm sorry that I keep doing that. I keep forgetting I need to put a period. 206.214. And it said round to the nearest hundreds. So that would be 206.21 because the 4 does not make us round up. Okay. And then, of course, all of these answers, you could be checking them to make sure that they are correct. I could check the last one for you just so that you see. So 5 times the natural log of 2 times, I'm going to press up and enter this. 2 times all of that minus 9 minus 12 equals 18, and you get a true statement. So whatever answers we've been getting, we should have been plugging them back in to check our work to make sure that we're doing our work correctly. Okay, let's go on to question number 18. Here we have log base 6 of 2x plus 1 is equal to log base 6 of 4x plus 5. Notice that the logs are the same base of 6 and there's only 1 on either side. So when that happens, it's almost like you can ignore those and all you're going to do is set the arguments equal to each other. So 2x plus 1 equals 4x plus 5. You're going to do reverse PEMDAS to isolate x. Okay, so I'm subtracting 2x, so now 1 equals 2x plus 5, and I'm going to subtract 5 because I need x to be by itself. So we get negative 4 is equal to 2x, and then I'm going to divide by 2 so that x equals -2, okay? But before you box it in, remember it is crucial for logarithms that you need to check your work. So I'm going to plug it into the calculator. So we have log base 6 of 2 times -2 plus 1. Okay, and I'm gonna see what answer I get, and then I'm gonna plug in the left-hand side, and then I'm gonna plug in the right-hand side to see if the values are actually equal to each other. Okay, so this one says not a real result. Let's see what the right-hand side says. Log base 6 of 4 times -2 plus 5. And it says not a real result. Okay, so the left-hand side is not real, the right-hand side is not real. What would happen if we plugged in everything together? Log base 6 of 2 times -2 plus 1 is equal to log base 6 of 4 times -2 plus 5. And it says true, so that's why this is misleading, okay? So that's why I'm asking you to do it separately, the left-hand side and then the right-hand side. Because if you went off of this, you would say that it's true. However, when you plug in the left-hand side, it doesn't work. And when you plug in the right-hand side, it doesn't work, okay? So this -2 is actually going to be considered extraneous. And now that we have no answer, the answer is not no answer. The answer would be no solution. Okay, let's go on to question number 19. Solve log base 6 of 3x plus 2 log base 6 of 3 equals 4. Okay, we have two logarithms with base 6 on the left-hand side. One of the logarithms has a coefficient, so I'm going to use the power property to make it the exponent of this argument. So this will be log base 6 of 3x plus log base 6 of 3 squared equals 4. Now there's two logarithms that are being added, which means I need to multiply the arguments. So this will be log base 6 of 3x times 9, because 3 squared is 9. And 3x times 9 is 27x. Okay, now I need the x that's inside the logarithm, so I need to do my little loop-de-loop. I'm going to underline the base, go out, and come back in. This will be 6 to the power of 4 is equal to 27x. Well, what is 6 to the power of 4? 6 to the power of 4 is 1296. So 1296 is equal to 27x. I'm going to divide by 27 so that I can get x by itself. So let's see if that reduces. Let's say 1296 divided by 27, which is 48. So x equals 48, okay? But remember that before you do that, I want you to plug it in. Not that I just want you to, it's a must. You must plug it in every time you're doing logarithms. So log base 6 of 3 times 48 plus 2 times log base 6 of 3. Okay, and I'm not going to plug in the right side because remember I'm asking you now to plug in the left side and see if it equals the right side, because for some reason the calculator is having some issues and it keeps giving us these triangles and it's leading us astray. So let's just do the left side and see if it equals the right side. So on the left side I plugged in x equals 48 and it says that it equals 4, and on your paper you will see that it says that it equals 4. Okay, so that's how we can conclude that this is in fact true. So 48 is our solution. Okay, let's solve the next one. Log of 2x minus 4 minus log of x plus 2 equals 1. Okay, so I have two logarithms. They have the same base. Remember that if the base is imaginary, there is an imaginary 10 there. None of the logs have a coefficient, meaning that there's no numbers in front. So I can focus on this minus sign, which indicates that we're going to divide the arguments. So this will be log base 10 of the first argument divided by the second argument, and then it equals 1. Now I can do my loop-de-loop. I'm going to underline the base, go out, come back in. We get 10 to the power of 1 is 2x minus 4 divided by x plus 2. What is 10 to the power of 1? It is 10. So 10 equals 2x minus 4 divided by x plus 2. Anytime you want to get rid of a fraction, you always multiply the denominator on both sides. Okay, and then this is going to have to be distributed. So 10 times x is 10x, and 10 times 2 is 20, and that equals 2x minus 4. I'm going to get x by itself by doing reverse PEMDAS. I'm going to subtract 2x. You get 8x plus 20 equals negative 4. I'm going to subtract 20. That gives me 8x equals negative 24. And then for the last step, we're going to divide by 8. And we get that x equals negative 3. Okay, let's plug it in and see what happens. We're going to, remember, I'm only plugging in the left side, and then I'm going to see if it equals 1, because 1 is what's on the right side. So we have log base 10 of 2 times negative 3 minus 4 minus log base 10 of negative 3 plus 2. And it says that it's about 0.9. Okay. Let me do that again. Came out all weird on my screen. I should have put the decimal when I started. Okay. So it was log base 10 of 2 times negative 3 minus 4 minus log base 10 of negative 3 plus 2, and I'm going to put the period so that it comes out as a decimal. And it says that the answer is 1, but then it says it's not a real calculation. Okay, so what does that mean? Now let's dig in deeper. So before in class, we had you plug in everything. We had you plug in the left side equals the right side and see if it said true or false. Okay, now if you get a triangle or some kind of error message, it is helpful to then focus on, okay, let me just plug in the left side, let me just plug in the right side and see if they're equal, and if they are, great, and if they're not, then there you go. But then now we run into this issue where I'm still getting a triangle. So what I'm going to do now is go in even deeper. So now I'm just going to focus on plugging it simply into the arguments. Remember that the arguments are what is inside of the parentheses. So inside the parentheses, we had 2 times negative 3 minus 4. And you get negative 10. And in the other one, you get negative 3 plus 2, and you get negative 1. Both of those arguments end up being negative. That you cannot have. Okay, so now we know definitively that this is not a correct solution. So I'm going to cross it out. I'm going to write the word extraneous on there. Okay, but wait, let me go back. The question said, what is the extraneous solution? Okay, well, there you go. The answer is x equals negative 3. But if not, then the answer would technically be no solution. But it didn't ask for the solution. It asked for the extraneous solution. Okay, now I wanted to go back and reiterate. Why can the argument not be negative? I'm going to have you make a note of that. Your argument must be positive. It cannot be negative or 0. It cannot even be 0. The reason why is because these are logarithms, and remember that logarithms have vertical asymptotes. And usually the vertical asymptote is at x equals 0 and everything goes up and to the right. That means that your x values, you cannot have any negative x values, and you cannot have an x value of 0 because that is where the vertical asymptote is. Okay, so if all else fails, okay, so let's say, okay, in class, we plugged this all in and we got true or false. If that doesn't work because you're getting a triangle error message, scrap it. Then what you could do is plug in the left side and see if the calculator says equals 1. Okay, if that still gives you a triangle message, then scrap that too. You're going to go in deeper. All you're going to do is focus on the stuff inside the parentheses. And if inside the parentheses you get a positive, you're good. If you get a negative, that is not a solution. Okay, let's try another one. Solve log base 3 of x squared plus 5x minus 15 equals 2. Okay, I'm going to do my loop-de-loop. I don't need to isolate this because it's already isolated. So when I rewrite this, it'll be 3 squared equals x squared plus 5x minus 15. Okay, 3 squared is 9. And because this is x squared, I know I'm going to need to move everything to one side. And I want to move it to the side where x squared is positive. And I'm going to get this to equal 0 so that then I can go and do my x method. Okay. So what two numbers multiply to negative 24 and add up to 5? Those numbers are 8 and negative 3. So my two factors are x plus 8 times x minus 3. From this factor, when you set it equal to 0 and subtract 8, you get that x equals negative 8. And from this side, when you set it equal to 0 and you add 3, you get that x equals positive 3. Now, there is the option that they are both solutions, or only one of them is a solution, or neither of them are solutions. And to figure that out, you're going to plug it back in and see. Okay, so let's plug it in only to the left-hand side. So we have log base 3 of negative 8 squared, and using the parentheses is very important. Okay, so notice that I put the square outside of the parentheses, and then we have 5 times parentheses again, negative 8 minus 15. And that equals 2, and that's what the paper said. So that means that negative 8 is a solution. Now let's try positive 3. So log base 3 of parentheses 3 close parentheses squared plus 5 times 3 minus 15, and that also equals 2. So that means that both of these are solutions, and I'm going to box in both of them. Or rather, I guess, let me box in the answers, D and A. So A and D are both correct. Okay, let's do question number 22. We're going to solve log, and there's an imaginary base of 10. So log base 10 of x plus 2 plus log base 10 of x minus 1 equals 1. There are two logarithms on one side, so I need to condense them using the properties I see in addition. So I'm going to use the product property, which tells me to multiply the arguments. So I'm going to do x plus 2 times x minus 1 equals 1. When I have two binomials, I need to do the box method to multiply them. So we're going to do x plus 2 times x minus 1. We get x squared, 2x, negative x, and negative 2. So now we have log base 10 of x squared plus x minus 2 equals 1. I'm going to do my loop-de-loop. Rewrite it in exponential form. You get 10 to the power of 1 equals x squared plus x minus 2. 10 to the power of 1. 10 to the power of 1 is 10. And then I need to get one side equal to 0 because this is x squared. So now we have 0 equals positive x squared plus x minus 12. Okay, the reason I want it equal to 0 is so that I can factor using the x method. So what two numbers multiply to negative 12 and add to positive 1? Okay, those numbers are 4 minus 3. So we have 0 equals x plus 4 times x minus 3. From this first factor, x plus 4 equals 0, we get that x equals negative 4. And the other one, x minus 3, we get that x equals positive 3. Okay, now let's not just go ahead and box them in. Let's plug them in and see if they're true or false. Okay, So I'm only going to plug it into the left-hand side, and I'm going to press enter and see if the calculator says it equals 1. So we have log base 10 of negative 4 plus 2 plus log base 10 of negative 4 minus, whoops, I messed up, of negative 4 minus 1. It says not a real result. So I'm going to eliminate x equals negative 4. Let's see if positive 3 works. So we have log base 10 of 3 plus 2 plus log base 10 of 3 minus 1. And that does equal 1. Okay, so notice that negative 4, it did not work. So negative 4 would be considered an extraneous solution. So I'm going to cross that out. And so the only answer would be x equals positive 3, which corresponds with answer C as in cat. Okay, let's do the next one. If f of x equals 2 times log base 3 of x minus 5, what is the inverse of f of x? Remember that for the inverse of f of x, all you need to do is swap x and y. So the first thing I'm going to do, though, is change f of x to be y equals 2 times log base 3 of x minus 5. Okay, now I'm going to swap x and y. So instead, I'm going to have x equals 2 times log base 3 of y minus 5. And I added parentheses because they didn't have parentheses there. Okay, and the minus 5 is not inside the parentheses. And now the goal to find the inverse is to get y by itself by doing reverse PEMDAS. So I'm going to start by adding 5. We get x plus 5 equals 2 times log base 3 of y. I need to divide by 2. So we have x plus 5 divided by 2 equals log base 3 of y. Okay, now usually we always have the log or the exponential on the left-hand side. So all I'm going to do is swap them around because the next step is going to be to do my loop-de-loop. Okay, so now that I have flipped them, I put this one here and this one there. I haven't done anything. I just switched the order. I'm going to underline the base, draw my arrow out, and come back in. Now I'm going from logarithmic form. When I rewrite it, it'll be an exponential. So we have 3 to the power of x plus 5 divided by 2 equals y. And then the last step is to swap y for the correct notation for the inverse of f of x, which would be base 3 to the power of x plus 5 over 2. And notice that that matches answer choice D as in dog. Okay, let's do the next question. If f of x equals 1/3 times log of x plus 1 minus 1, what is the inverse of f of x? Okay, so we're going to do the same thing. I'm going to start by writing it with y instead of f of x. And then I'm going to swap x and y. So it'll be x equals 1/3 log, and this has base 10 because it was imaginary, so I'm going to add it there, of y plus 1 minus 1. We're doing reverse PEMDAS, starting with what can you add or subtract. I'm going to add 1. We have x plus 1 equals 1/3 log base 10 of y plus 1. Now this 1/3, I'm going to multiply both sides by the reciprocal or the denominator, which is just 3. So these cancel out, and on this side, the 3 has to be distributed. So we have 3x plus 3 is equal to log base 10 of y plus 1. Okay, now all I'm going to do here is again flip the order so that the logarithm, you want the log, you don't need the log on the left, but it is how we saw it mainly in class. So if it helps you to have that same order for the loop-de-loop, you can keep making sure that the log is on the left, although it doesn't necessarily have to be. Okay, so now I'm going to underline my base. I'm going to go out and back in. I'm going from logarithmic form to exponential form, so it'll be base 10 to the power of 3x plus 3 equals y plus 1. And the last step to isolate y would be to subtract 1 and then write y as the inverse of f of x. So the inverse of f of x is base 10 to the power of 3x plus 3, and then outside the exponent a minus 1. Okay, so notice that that matches answer choice B as in boy. Okay, we're almost done. Question 25, we're going to find the inverse again. These steps are going to get kind of repetitive. Change f of x to be y, and then swap x and y. So x equals 1 over 5 times 5 to the power of y minus 2. Okay, now there is nothing to add or subtract because this moves as a unit. So the only thing that's not part of that would be the 1/5. I can multiply by the denominator on both sides to cancel that out. So now we have 5x equals base 5 to the power of y minus 2. I'm going to switch them around again so that the exponential is on the left-hand side. Equals 5x. And now we're going to do our loop. So I'm going to underline the base, go out, come back in. Now this was going in started as an exponential, so now I'm going to write it as a logarithm. So log base 5 of 5x equals y minus 2. And I'm going to do plus 2 on both sides because I need y by itself. But after you have y by itself, you want to write it as the inverse of f of x equals log base 5 of 5x plus 2, which matches answer choice A. Plus 2. Sorry, I forgot the plus. Okay. Question number 26. Another inverse. I'm going to change f of x to be y. And then I'm going to swap x and y. Okay, I want to get y by itself. I'm going to subtract 2. X minus 2 equals negative 3 times 4 to the power of y. I'm going to divide by negative 3. Okay, now the exponential is on the right hand side. I'm just going to swap the order, put it on the left so that I can do my loop-de-loop. Now in exponential form, when you rewrite it, you have to start with the word log. So log base 4 of x minus 2 over negative 3 equals y, which is the same thing as the inverse of f of x. Okay, so that would correspond to C, I believe, log base 4 of x minus 2 over negative 3. Okay, here's the last question. We're another inverse. And change this to y. And then I'm going to swap x and y. So x equals base 6 of y divided by 2. Okay, now there's nothing that's being added or subtracted or multiplied to the base. So I need to go straight into rewriting it by doing my loop-de-loop. But I'm going to just put this on the left side. So I flipped these around. Okay, now I'm going to do my loop-de-loop. Underline the base, go out, come back in. This is an exponential, so the inverse will be a logarithm. So log base 6 of x equals y divided by 2. And then to solve for y, you need to multiply 2, the denominator, on both sides. So the inverse of f of x is 2 times the log of base 6 of x. Okay, which is answer B as in boy. Okay, that is the last question. I hope that this has made sense and it has clarified some misconceptions that you have. If you still have doubts about something, please feel free to reach out in person, and I'll see you guys in class.